For 5, we are evaluating it from an integral from 0 to 1. Again, we're choosing our u. We have our inverse, so we choose our u to be tan inverse, and then our remainder is just dx. We use our green thing that we were supposed to have memorized. We have our u, which is tangent inverse. We have to find the derivative of u, which is from our chart that you need to have memorized. And then our dv is everything else. And then we need to find v by taking the antiderivative, which is x. And then we check that by taking the derivative of x, which is just 1. So it worked out, okay? Now from here, we were given, again, the left-hand side. So now we're going to rewrite it as the right-hand side. So this whole thing right here is the left-hand side, and we're going to rewrite it as this over here, okay? So this is equal to this. So we have u, which is tangent inverse, times v, which is x. And because we're evaluating it from 0 to 1, we also have to do it here from 0 to 1, minus the integral from 0 to 1. V is still x, and dv we found to be 1 over 1 plus x squared dx, okay? Cool. So again, whenever you're doing evaluating, we start from the top and you subtract it from the bottom. So I went ahead and did that. We take this, plug in ones, and then we subtract and plug in zeros. Whenever you use subtraction, you should always use brackets or parentheses, because if it's more than one part, you're going to have to distribute that negative. I would just practice whenever there's negative, just use brackets, okay? So over here, I'm going to move that x to the top, and then we'll keep going from there. Alrighty? So over here, this 1 will just go away, and we're left with tangent inverse of 1. If you look in your notes on page 44, example 2, we use our little inverse trick. So I'm just going to set this green thing equal to z, okay? So the trick is, if you want to get rid of the inverse, you actually flip these, right? So the z comes here, and then the 1 comes on the other side. So now, tangent is the same thing as sine over cosine, right? Sine over cosine is the same thing as y over x. So essentially, we need to know where on the unit circle is our x and our y the exact same thing. So that's either going to be in quadrant 1 or quadrant 3. But remember, in this same section on page 44, for inverse, there is no quadrant 3. So you can either go from 0 to 180, or you can go from 0 to down to negative 90, okay? So our only answer in this case would be pi over 4. So tangent inverse of 1 is pi over 4, and then we still have minus our inverse, okay? Now, if you look on page 62, we have this little thing right here. Whenever you have a fraction in this form, you should check to see if whatever's on the bottom, if you take the derivative of it, does it look kind of like the top? And if the only difference is a scalar or just a number, then you can use this trick, because you can always pull numbers out to the outside, okay? Or you can, if it's times 2, then you could divide it by that 2, which we'll see in just a second, okay? So again, we have that 1/4 here. And then, so the derivative, so our bottom in this case is 1 plus x squared. And on the top, it's supposed to be the derivative of the bottom. The derivative of the bottom here is just 2x. So there's supposed to be a 2 here, but there's not. So if we add a 2, sorry, not add, if we multiply by a 2, that means we also have to divide by the 2 so that they cancel out, okay? So now this whole red thing right here, with the 2 included, because that's the derivative, is now equal to this red part right here. So we leave the 1/2, and then we rewrite it as the natural log of whatever's on the bottom, which was 1 plus x squared, and we are evaluating it from 0 to 1, okay? Again, when you're evaluating, you start from the top, and then you subtract it from the bottom. Whenever you subtract, you should usually use parentheses, but in this case, it's only one part, so we don't have to do that. Don't forget that this half is multiplying both of those things, so that's why I put both of them in brackets, okay? Just do a little simplification. We get natural log 2 minus natural log 1. If we look at the graph of natural log, we know that ln1 is 0, or you could just have it memorized, or you could just plug in your calculator, however you want to do it, and then this would be our final answer.